Welcome to Moose Model Boats, where you can see videos and photographs of operating scale model boats and tanks, as well as helpful guides on how to detail and modify models for radio control systems. I also have links to other interesting sites, as well as information on personal 3D modeling and printing of a model. I imagine in the hobby world that there's some debate about whether or not 3D printing is applicable for model building. Some people probably think it is great, and some people have just the opposite feeling. That's just some sort of a high-tech tool that really doesn't deserve recognition. I happen to be on the side of enjoying a 3D printer because I do have one. I've had one for about a year and 4 months now. Now, as far as whether or not it's a good tool, that's up to your own discretion. But think about it: if you graduated from sort of making a model with a pocket knife or pen knife or some sort, maybe some sort of a sharper blade, maybe more of a high-tech type tool. You've graduated from using probably some sort of an old-fashioned ruler to maybe a steel ruler to using tape to fastening things together to some sort of better clamping mechanisms, conventional screwdrivers to a powered screwdriver, and a variety of things, needle files, saws, powered tools of all sorts, and maybe some sort of a, instead of eyeballing a water line on a boat, you might have some sort of a tool that's adjustable like that, and all sorts of accessories. So then that begs the question about where does it stop? 3D printing came out in the late 1970s or early 1980s, so it's been around for a long time. The systems back then were very costly, and they were very large, and not something that everybody would have in their home. In fact, I don't know if anyone really had one in their home unless you had a lot of money. Typically, the lower end systems was $15,000 to $20,000, and now we're talking about $1990. I was involved in these purchasing of computer-aided design software for my company, so I did a lot of investigations and looked into these 3D printers and saw many of them operating. Now, I was reintroduced into 3D printing in 2016 when I decided to do my own design work. First, I actually bought some parts on Shapeways, where you can buy something that's actually pre-designed and listed in a catalog type listing, or you can hire a designer to do so. Well, I actually downloaded some software. You can get some free software. This one is I love this version. Unfortunately, it hasn't been supported for a couple of years now, but I keep using it all the time. It is extremely simple and pretty powerful at that, and it gets the job done. This is made by AutoCAD, and it is called 123D Design. As I said, you might be able to find some places where you can download it if you wanted to. There's some other freebie sites out there. This one works great for me, and I just love it. It's just so easy to work with. And you can see all of the kind of complicated shapes I have in here and everything, and it wound up that it performed extremely well. Have no problems with it, even though it isn't supported and hasn't been for a couple of years. So here is a somewhat simple design. This is an H-bit used for a model tugboat or towboat, and you can make it any size. Once you design something like this, you can resize it extremely simply just by clicking on it and then saying that you want to resize it to whatever scale you want. I can make it half of that, twice that, 10 times that, quarter that, 0.35 times that size, whatever you want, and it's done almost instantaneously. So I can design one and make several different variants of it at different sizes. You can start out with geometric shapes. This one happens to be a cube, and we can make it, say, 0.5 by 0.5 by 0.5. And we can modify this cube. We can change the width of it, the height of it, etc. We can round corners. You can put chamfers on it. You can drill holes in it. Now, drilling a hole in it is a little bit different because what you're doing is you're taking another shape and you're going to subtract out the difference between the two. So you can see we have the hole goes right through it. Turn the grid off so we can see a little bit easier. We can merge parts. I can take another shape, and we've got a library of shapes up here, and we can actually change what the shape looks like. We can change the direction of it, rotate it any way we want. We can move it. Here I stuck one shape inside the other one. Now, I know this one doesn't make much sense, but we can, or we can add it together and merge these. And now we're just going to change the color of it so I can show you that this is all one piece. And if we want, we can come in here. We can drill out that particular shape inside so that that hole goes completely through, like that. We'll subtract that out. And that's how we build things up. Started out with a little rectangular plate with some radiuses on it. Then I added some cylindrical shapes coming up here, and a cross piece and some round discs on it, and merged everything together. I added a little triangular shape piece in here as a support, and then drew that and merged all that together. So, and we can even radius out little corners all inside here. We can do all sorts of stuff. You can put threads on things, almost everything you can imagine. And just think about making something like this before you had this kind of a tool. You would have these rods, you'd have 4 rods and these little caps that you'd have to make. Here I've got one item and I can print it. Just design it like that and just print it out. And on Thingiverse is neat because you can search for almost anything you want here. Say, well, let's do a army. We just select on army, and we'll look up. And what do we have listed on army? All sorts of figures, tools, tank type vehicles, and it goes on and on boats. And there's a variety of things, even some logos here you can download. And you can download these files and send these files to your printer. You can also resize them. So it depends, doesn't matter what somebody designed online, you can always make a different size. There's hundreds of thousands and probably millions if you add a different kind of sources for it. Not only Thingiverse, but there's a whole load of other places where you can find these things. Some you have to pay for. Thingiverse has everything that they have out there is for free. So what I'm going to do next is I'm going to show you how the process works. I'm going to open up in my folders. I have downloaded files that I have, and my son wanted something printed for a Nerf gun. So here is what was known as a peg, and apparently this thing allows you to put a 7-shot cylinder on a Nerf gun as opposed to a 5-shot cylinder. There's also the files for the cylinders, and these were all free. You found them on Thingiverse. So he wants to modify a Nerf gun to do this. So what we're going to do is we're going to look at this thing and analyze it a little bit and 3D print it. We're going to take that file and we're going to open it up in what's called a slicer. Meat machine or cheese machine at a deli where it slices up the cheese or meats to a certain thickness and you just stack them up. Well, this just does the opposite. It takes slices up all of the different layers and it puts them back in order so that you're building up your part layer by layer. So let's come in here and we're going to take that peg, which is an STL file, a stereolithography file. Vertical shapes are in the vertical position, so we're going to take this object and we're going to rotate it so it sits vertical. And then we can move that wherever we want, put it on the plate I'm just going to move it up to the front right corner where I can print it out. So that's basically it. Now we're going to slice it. We have some settings we can go into the slicer. And what the settings does is depends on types of material that you're using. You want to, it'll set the printer temperatures, the temperature for the print head and the plate that it's sitting on, which is this. We can also fill density, so we're going to change this to 100% density, so it's going to be solid. And I've been printing ABS, which I like a lot. And we're going to look at everything, and we're going to generate support, because with the filament as it's building up, if we notice right in this area here, this top is bigger than the bottom. So it's going to generate some support pieces in here. So as it builds up the top, it has something to lay on, and then that'll break away after we're done, after we take it out of the printer. So I've got all my settings done, and I say prepare. Now it's going to make what's called a G-code file. If you're familiar with machining, you know that tells the machine what to do. It tells the machine to come down, to move over, back, up, so on. And this place, in case instead of up and down, the plate is actually moving down, up and down, because the printer head on this particular model is only moving in those two axes. And say send. And I'm going over my Wi-Fi. It says send. And so I want to print now, yes. And you hear the 3D printer start. So let's talk about the printer a little bit. This is a QIDI X-Smart. Bought it in late 2018, and it's been upgraded a little bit. Different color cabinet, a little different shape to it and everything. But essentially the same. It's got the single nozzle on here. It cost $500 on Amazon. I made some modifications to it. Biggest modification, if you want to call it a modification, is because the printer is about 40 pounds. I have this Lazy Susan on here. Ball bearing, very nice, and that keeps the printer nice and stabilized. And that's so I can change the filaments spool. There's the ABS filament. I also changed the mounting for it. It originally had a big knob that screwed on. I just made this little bracket, so I just laid the filament spool right on there like that, and I made a little wedge that goes in the back, underneath the back here, to move the feed tube so it goes down to the bottom center of the spool. You can see this piece of tubing that goes in here and goes inside. That's where the filament runs up from the spool up. It goes down inside the head to the nozzle. What's nice about this printer is that it's completely enclosed. The sides come off pretty good. There's just some magnets holding them on there, so if you need to get in there and do some sort of cleaning or maintenance or repair. Cuts down on the noise quite a bit. So now the printer's warming up. Let me get in a little closer. And what will happen is that the nozzle, which is on the bottom side of this block on the left here, that's sitting on the rails, nozzle sticking down, the bed is going to come up and contact, just barely touch the bottom of that nozzle. And that nozzle is going to be squeezing out the ABS filament in a very, very thin hair thickness, and it's going to place it on the bed now, and the bed's going to be moving up and down, and the nozzle is going to be moving back and forth on the shaft that you see here. There's two shafts actually, and there's a shaft on each side where it would be going back and forth in this direction. So, and that's as it's depositing the material onto this plate. The bed is heating up and the nozzle are both heating up. And when it starts squirting out that little filament onto that plate, and the plate is going to be going gradually down, and this nozzle is going to be going back and forth and forward and back, depositing that filament on that heated plate. The heated plate is going to help everything fuse together better. It's not at a melting temperature, just below the melting temperature of the ABS, but enough to keep the melted resin filament to stick to the what it already deposited on the plate. And the temperature right now of the nozzle is 172, 175, 176. It's going to go up to 220 is what I have it set at. The bed is set at 75 degrees C, and right now it is at 70 and climbing. The downside of this printer is the bed limit, or the size of the part that you can make. It is 6.7 inches wide by 5.5 inches, 5.5 inches deep, and 5.5 inches tall. Now, I've made parts much bigger than that, and what I do is just design them and split them in half, a quarter, or whatever it is I do, and then print them out and then glue them together. A good example of that are the bulwarks that's on this sprinter tug. This is 18 inches long, so the bulwarks along the side here, and across the back, this is actually one piece that comes over about here, the mirror of it on the other side, another piece here, and the bow piece, and between the toe knees. So they're all separate pieces that were glued together and then glued to the hull. The model I was showing you earlier is the pilot house. This is what it looks like, and it works really well. And right now the radio turned off, but the mechanism is pretty good. Everything on this boat, basically from the deck all the way up, and the mechanism down inside, and some of the brackets and stuff that I have inside the hull, it's all 3D printed from this little thread printer. Eventually I'm going to be putting tires. I have a whole bag of them that I printed out here in ABS, and I'm going to be, it's hard to see the detail in these things, but the threads are incredible, and these will be placed all along the sides of the towboat. And the plate's going to be pretty warm. Probably fry eggs on there. And I'm just going to snap that off. And you can see this little ring that's around here. We're going to take a little X-Acto knife and cut that off. And that will be our part. And we'll compare that to what it looks like on the real drawing. Okay, here's the 3D model. And here's the 3D part that we just printed. And we're going to take a little sandpaper. We're going to clean it up. Basically, all I did is I popped off the printer and I popped off the support. There's a little bit of it left in here. And we're just going to clean this up a little bit, and hopefully that'll work. I guess the proof is in the pudding. It's when it actually goes into where it's supposed to fit, and see if everything slides in nice. So that is the whole process, from model to going to the slicer, which creates the file that goes to the printer, going to the printer and printing it out and coming out with our part.